good, a lot of fingers. Okay. So now we're going to get closer and closer. We may not write much code today, but that's okay. We don't have to. We got to make sure we get the concepts first. So let's now talk about the terminology. What we're going to point to with each one of these things typically is not going to be the objects themselves. In other words, we're not going to modify a string object so that it points to another string object, or a student object such that it points to another student, because that makes us change the actual element type. And that's really not what we want. We don't want to have to go in and modify the class itself. What we want to do is think of a linked list more like a train car, right? Where this train car could be holding one of many different things, right? Let me get back to my PowerPoint here, right? So one of these train cars could be holding one of many different things, right? You could have one that holds passengers, one that holds grain, one that holds coal or oil. So these cars can handle sort of interchangeable kinds of things. The car doesn't care which student is riding in that car, right? That's sort of immaterial. So the linked list is actually made out of these things called nodes, and the nodes are the things that are actually linked together. It's like a whole series of train cars that are linked together one after another, okay? So that's called the node, right? The node's the train car, okay? The next thing is that each node typically has two pieces to it. You're going to have the data part, which is the actual load that's in the car. Like this is a passenger, or this is a load of coal, or this is a load of grain, or this is a load of whatever, right? Whatever it is you're transporting. So the node is going to contain a data part, which is 99% of the time a link to an object, right? Because what you're putting in these things, as with all data structures, just like we did with the array list, what we're putting in here is objects. A student object goes in this car, and another student object goes in the next car, right? So it's going to have a data portion, which is the element that you're actually carrying around. And then you're going to have a reference part, which is the connection between the two train cars. So you'll notice the way that this is going to be structured in our little diagram here is if my data is strings that I'm carrying around, like the student names, I'm going to have a node that is going to be of the proper type so that it can point to a string, right? So the data part is going to point to some object like this string that has a student's name in it. But then it's also going to have another part called next. And that next is the reference to the next one in the list, right? The next one back. So a data part and a reference part. The reference part is almost always by convention called next, which kind of makes sense, right? I'm one train car, the next train car is right there behind me, right? You don't always call the data part data, it doesn't really matter what you call that part, but they will have these two pieces, right? If you have questions, certainly stop.
Does next, is that the next node or the next data?
That's right, it is the next node. Right? Because the nodes are going to be the things that are actually connected. Good question, Henry, right? So this is going to be another node. Writing with the mouse is very bad, but you'll get the idea that this is then going to point to this guy, right? And this guy would have its own string, right? So the nodes are the train cars and they always point to each other. Yep, thank you for clarifying. All right, anybody else? Bjorn, go ahead.
Do the nodes have a pointer to the next one and the back? Or the backwards null?
That's right. If you wish to do that, right? If you want to make a typical linked list, you go only this one direction. But if you want to make a doubly linked list, then you would have two references, right? It would have a data part and then two references. One is called next, and by convention, the other one's called previous, prev, right? So next and prev. So if you wanted to have a linked list that you could go to either end, you would have a front and an end, and they would point in, and then the nodes would point to each other all the way down the line. Absolutely. The cool thing here is there are no rules, right? There are no rules. It's your references, right? Do whatever you want with them. You want to go backwards, you want to go forwards, you want to go sideways, you want to come up with some other crazy stuff. It's just references, folks, right? You can use the references any way you like. So all of a sudden, this is why I say this is the moment where I thought, like computer science started opening up a lot, because I thought, you know what, you can build anything you want, right? There's no rules here. You can build anything you want, right? And it's all just references, right? It's just maintaining the references and being smart about them. That's it. Okay. So we're going to talk about some fun variants like doubly linked lists and circular linked lists. And like, yeah, we're going to go some really fun directions here. Okay. All right. Any other questions so far before we talk about a couple other terms? We may not get to much code today. That's okay, right? We got to understand the concepts. We'll get to the code. Okay.